issue that impacts a lot of us. At the state level, we have already done a lot. Our legislators, a few of whom are actually with us this evening, have passed a series of things over the last 2 years that are going to be moving the state in a forceful direction towards a decarbonized future. This really, Washington State is not a large state looking at the rest of the country, but we are influential, and this could give some courage to other states to show up as well. So here we, whereas other states, they're saying, well, should we move forward or not? Here we're saying no. We're moving forward at the state and the city level. The question is for you professionals, what's the smartest, most cost-effective, sensible way to get there? And this is Easter Island. So hold this image in your mind for a while. We'll come back to Easter Island. Our big picture for Seattle, I made this diagram several years ago, which has gotten me in trouble a few times already, but the idea was, you can see the population line going up on the top there, that dotted line. We're growing, but at the same time, we wanted to shrink that red triangle of fossil fuel use down to very close to zero, and grow our clean electricity as much as we can, with solar, wind, whatever we can do to increase our hydro. But you can see the big triangle on the white one is we got to do most of this with efficiency. The trouble with this diagram is that the last couple of years in Seattle, we were going the wrong direction. The red wedge was actually growing instead of shrinking. I just happened to see this notice in the ASHRAE newsletter a few days ago that Mayor Durkan was in Scotland and signed this executive order, making it more clear that yes, we are going there, and that 39% below the 2008 baseline, that's not 39%, on a square foot basis. That's overall. So while our existing buildings are going to have to do something serious, our new buildings really have to step up there. And the other thing that's highlighted there is that building performance standards. You're already familiar with the state's requirements that are phasing in now. Seattle will add that we'll capture buildings from 20,000 to 50,000 square feet as well, and we'll add a layer on that for carbon emissions to go along with the state's requirements for energy reduction. So you'll see this diagram a few times, but the bottom line here is the bottom line, which is that the things we're building now in the 2020s have to be good enough that in 2050 we don't have to do any major surgery to them to make Seattle work as a carbon neutral city. The first one of those, eliminate combustion. Okay, the idea being that if you're going to be carbon neutral in a couple of decades, you don't continue to install gas-fired equipment right now, right? That's not going to get us there. And besides, the whole idea of burning things indoors has had its day. And yeah, these people sitting around their fire are burning wood or dung or whatever it is that they had. We switched to coal, a couple of centuries ago, and then to oil, and then finally mid-century to gas. None of these is good for you to be breathing while it's burning inside, right? And they have some bigger environmental impacts as well. But we can only get off of these now because we have alternatives. The problem that we're up against, of course, is that gas is popular. It's still fairly cheap, even though prices have gone up a bit. The equipment is cheap and compact, and you love that blue flame image. Even I got one of those fancy new electric magnetic stoves a couple of years ago, and the graphic they use under the glass to show which burner you've just turned on is a row of LED lights that are made to look like gas flames. But anyway, 90% of our gas use roughly is those two big ones, space heating and water heating. And then the remainder, cooking, decorative fireplaces, some dryers, things like that. But the idea is that in Seattle, we're going after those two really big uses. And the other advantage, of course, is that those little ones are the emotional ones. I think that I have perfectly liberal friends who probably protect their gas cooking the way that people in other states protect their guns. But this is where we're going. Pick off the big uses now, and we'll deal with the little uses some other time. So one of the big ones for Seattle is, okay, space heating goes to heat pumps. And we did put in a long list of exceptions for small loads, little ones, and for auxiliary heat in really cold weather. We didn't put any exceptions in for continuing to use fossil fuel. And note the red text at the bottom that right now we're in the midst of this process to propose similar rules for the state, and it's being, of course, hotly contested, and it'll be something that you two organizations can decide how you want to weigh in on this discussion. And for one of the highlights of the evening tonight, you have an architect here going to explain to a big room full of engineers how a heat pump works. But in my sketch there, you've got one of these heat pumps in your kitchen. It runs this fluid through the back of the fridge that's cold enough that it's actually pulling heat out of that already cold air, squeezes it really hard so it gets hot, and then that radiates out into the rest of the kitchen. You run it back through that valve at the bottom and circulate it again. The same thing happens with the building, that it's cold outdoors, but what we call cold, it's not cold compared to Fairbanks cold, right? There's still a lot of warmth in that air, and we can retrieve that heat at triple the efficiency of generating it new. And I would even go so far as to say a heat pump is a renewable energy source, because look over on the right, even in the winter, sun comes in, warms up the atmosphere. The heat pump just takes that air that's just been brought in and separates out some heat to go into your house while colder air comes out the other side of the heat pump back into the environment. And that allows you some nice, cozy warmth that'll keep your cat happy inside. The next really big one is heat pump water heating. And this one just kicks in at New Year's, so several weeks from now, for new applications. But for hotels and multifamily buildings that have central water heating, which is most multifamily over a couple of stories in Washington State, you use heat pump. And in fact, the Seattle City Council will be considering in a couple of weeks an amendment to this that would bring in commercial buildings as well that have substantial water heating rules. Once again, see the red text on the bottom. This is currently in front of the State Building Code Council and is hotly contested. So I call my talk the tug of war, because this is not just a Pollyannish thing where we're going to like cheerlead for this stuff. I wanted to just recognize that the opposition is very real and very vigorous. Obviously, if you're in the gas industry, we're talking about removing revenue from your stream. Not popular. Developers, of course, are always opposed to anything that increases construction cost, and manufacturers, especially U.S. manufacturers, have been saying that they're not ready to go yet. And so you can see those objections below. We have good responses to all those objections, but you will hear them and variations on those over and over. Another one, though, is that you can take away gas heating, but then you don't want to just replace it with electric resistance heating, except in very small situations, because we have these giant hydro plants, but there's only so much of that to go around, and we're going to need a lot of that power to run electric vehicles over the next couple of decades, and to convert many or most of our existing buildings that are running on fossil fuels right now over to heat pump. And so we got to not waste it. This toaster oven in a hotel is basically what electric resistance is, right? It's 100% efficient. You run power through those resistors, and if you put a little fan behind it, then you've got a hairdryer, right? You can blow air over that, and that's the way a lot of our buildings are heated. In fact, we go to extra expense to cool the air down, push it all through the building, and then just before it comes in your room, so it doesn't freeze your head off, it warms it back up with electric resistance. That's just got to go. Along with this, carbon isn't our only problem. Refrigerants are another big one, and right about half of all refrigerants manufactured end up in the atmosphere, and some from slow leakage, but mostly from periodic catastrophic events where the whole system dumps out. So our legislature has said, no, we're going to start squeezing that along with California and some other places. Instead of having global warming potentials of 1,500 or 2,000, we'll be down below 750. And for water heating, hey, you can use CO2, and that's got a global warming potential of exactly 1, right? All the big equipment manufacturers are now crowing about their new low GWP refrigerants that are coming online, and so that's actually taking care of itself. I think largely thanks to California and to Canada. The building envelopes that we're building in the 2020s will be on buildings unchanged for longer than anyone in this room is alive, right? Those, it's really expensive to upgrade a building envelope, and it just about never happens. We have high rises downtown Seattle that are 60 years old now, still the original skin, single pane glass, the whole business, because just really nobody wants to touch that. So if the building envelopes that we're building now really have to keep the interior as comfortable as possible. I should say that I got a chance to talk to my colleague in Lisbon about what we were up to, and she was very dismissive. She said, "Oh, you Americans, all you're just about heat pumps. We don't have heat pumps in any of our social housing, and we can keep them nice and comfy because we keep the sun off the windows and we make sure there's good cross ventilation, and it works like a charm. Why don't you wise up?" So there's some real value there. With the building envelope, we're talking about one significant thing we've done is to say from now on, the passing that air barrier test is mandatory. You got to pass to get your certificate of occupancy. At the old standard of 0.40, we have reduced the test standard to 0.25, but in between 2.5 and 4.0 is where you can still do like the old routine, and just if you're in that range, you just do your best job to fix up the leaks you can find and write a report. But that's serious business for especially jurisdictions outside of King County that have not been pursuing air barrier testing. This might be kind of scary for your local contractors. And in addition, since about 2/3 of the heat loss through building envelopes is through the fenestration, we've really ratcheted this down. In Washington state, it's a little better than national codes. In Seattle, our standard for curtain wall is similar to what it is in Minnesota or something, and for punched window openings, it's well beyond that. But we set these because we were able to find projects that met these criteria still with double pane glazing, so you can get there. The other one other highlight of building envelopes is our concrete balconies that stick out, like the radiator fins off a motorcycle. You can it's a really effective way to get rid of heat from buildings. So now you got to put in one of those structural thermal breaks that are pretty nifty and have just come down in price a bit. Or else you have to treat it like an uninsulated a concrete face of your wall and balance it out with the rest of the building using this 0.74 U factor as opposed to the 0.056 or something that you would normally use on the building. So it's you don't probably want to go there anymore. In our whole energy modeling routine has been switched around. We're using the ASHRAE Appendix G method. My thought there is that it is less susceptible to monkey business than our old one, which you could always find ways to make your baseline case look worse. And we have changed it from the ASHRAE system. Instead of site energy or energy cost, we're evaluating, our metric is carbon emissions, and it's carbon emissions compared with the emissions that would have happened if you build your same building to the ASHRAE 2004 standard. That's going to be our stable baseline. So if you look where I've circled office in red, at the Washington state level, you could only emit 54% as much carbon into the atmosphere from your building as would have happened under that 2004 ASHRAE. And in Seattle, we go 10% better than that to account for the fact that our other parts of the prescriptive code are so much more stringent. And that picture, anybody who's ever been to architecture school had to identify that on a test. And it's this fascination we haven't been able to let go of, this floor to ceiling, wall to wall glass, and it's just about to hit its 100th birthday. And so there have been 4 generations of architecture professors oohing and awing over this thing. We got to get over it. But anyway, we're saying now that in Washington state, your building envelope, no matter how you do your modeling, cannot be made any more than 20% worse than prescriptive code. And in Seattle, it's 10% worse is your maximum. So if you can figure out a way to replicate this lovely all glass building, go ahead. That bottom bullet, what is modeling good for anymore? You'll have to figure that out, because up till now, all you modelers have been able to sell your services to clients by saying, hey, I can get rid of your slab edge insulation and I can get you 63% glazing and all that. It might not work anymore. Finally, there's the generate power. To the extent that we can, we got to start like using our roof space that's not otherwise needed for anything to augment the hydropower we have in the area, at least to get, the baseline energy for a building, a commercial building, even on like Sunday morning with nobody in the building, is usually 20% or more of the peak energy. There's a lot of energy. At least we should cover that. The requirement in Seattle is for 1/4 of a watt per square foot of conditioned area. So if you got a 20-story building, it's a third of your roof area is covered with solar. That includes the walking spaces. If it's a 2-story building, it's just a few percent. We did one little maneuver in there. We said affordable housing projects don't have to do this, and other projects that don't want to put solar on their own roofs can build their solar array on an affordable housing project if they want. So we're already seeing some interest that developers calling up and saying, okay, where do I find an affordable housing project that wants my solar panels? So could be a match made in heaven. This is there's serious issues. Like I mentioned earlier, some people are worried about City Light being able to or other utilities being able to handle the whole load on the grid. We just had a 1.5-year study by EPRI, and yes, our grid can handle that. The local distribution network probably will over time need to get modified some handle, and over these next couple decades, as we move towards that decarbonization, we're going to have to do some things in the code to make sure that we're still not endangering the utilities capacity for real cold or real hot weather. Gas is a rough industry to be in anywhere in the country, I think, right now, but especially on the West Coast, where we're working on making all that burning of carbon go away, and so that industry really has to get going on sort of reinventing itself and not just watching their loads shrink. Back to Easter Island. Several hundred years ago, this was a heavily forested island. It's about a little less than the area of Seattle. Was this thriving big civilization and seafaring people, very well organized, and they had a terrific kind of palm tree that was good for boat building and rope making and houses and moving these giant stones around the island. They got to the point where they were over harvesting more than it could replace. As they were harvesting too much, the topsoil started running off so that new trees wouldn't grow in those same places. Eventually, I'm sure they cut down the last tree. They must have been aware that they were cutting down the very last tree on the island. Then they couldn't build boats anymore and replace their old ones, and so their main source of food disappeared. And when Europeans first came upon the island, there were just a couple thousand people left, just sort of barely alive on the island, having wiped out their whole existence. And in a microcosm, that's where we're at. And so they didn't have the science to kind of look ahead and see what was happening. We do, and it's just kind of a big worldwide IQ test whether we're going to take action on what we know is around the corner for us. So with that, thank you all very much.
Yeah, thank you very much, Dwayne, for your great presentation on tug of war of decarbonization. Next, we have Don Colliver, and he's going to be presenting decarbonization targets and building-related technical issues to reach the goals.
Okay, so thank you very much. Can you see my slide?
Yep.
Okay, good. Well, first of all, thank you for the invitation to be here and to discuss with you something that's critical to our world. And certainly over the last couple of weeks at the COP conference, or COP26, the UN conference. COP is the conference of parties. UN calls nations parties, so that's why it was called the COP. And unfortunately, I've not been able to update this with some of the things that happened last week. But what I do want to do is spend just a few minutes here with you talking about some of the targets and some of the issues that we are having to deal with related to buildings. So first of all, we all know that climate change is a global problem. It's not just necessarily for here in America. And we also know that CO2 emissions are a major contributor to this. Now I've got some figures that I'll show in a moment about how much of a contributor it is. The issue is that there are a lot of goals that have been made, but the problem is that how to reach those goals is not real certain. There's a lot of uncertainty to it, but there are two known features to that. First of all, it's going to require some technical firepower. It's going to require engineers and architects working together in order for us to achieve this problem, achieve a solution to this problem. The other component is this is not just America's problem. This is not just a Canadian problem. It is a worldwide problem, and we do have to have coordination and international cooperation around the globe. So, yes.
Sorry
Yes.
to interrupt you. It looks like what's on your screen is actually the PowerPoint itself, and it's not in slideshow mode.
It's not
So
in
we
the
can't.
slideshow.
No, we can only see the first title page right now.
So, okay, what has happened then? Sorry about that. So let me figure out. So you're not seeing.
We're seeing. So now we're seeing why is it important. Now we're seeing introduction.
Okay, so
Yeah, we're seeing the PowerPoint, but we're actually not seeing the slideshow. So if you click on your slideshow, so your whole screen comes on, Don.
that's what I had.
There you go.
Okay. Okay, you
Perfect.
got it now.
Yeah.
Sorry, sorry for that. But so this is what I was talking about. At the end, what we must recognize is that engineers and architects are going to be able to make a difference, because we do need quite a bit of technical firepower in order to achieve that. So my objectives of discussion today is, first of all, what is decarbonization and what isn't it? There's a lot of myths about that. Second of all, I want to talk about where are the sources of these greenhouse gases. Then let's look at some of the policy goals and the targets that are set by governmental groups. And what I'm trying to do is step this up a little bit higher elevation than Dwayne was talking about what was happening in Seattle or Washington. What are we going to be looking at is more of the worldwide view. And then there are a lot of technical issues that have to be addressed in order for us to solve those. We don't have to solve all those at this stage of the game, but to put perspective of this whole thing, let's look at some of the issues that need to be addressed in order for us to achieve these goals. And then finally, what can ASHRAE be doing to solve this? Okay, so let's first talk about building decarbonization. And the key component here is D, carbonization. The prefix D, it is not total reduction of carbon. It is the process of reducing or eliminating the gas emissions. And we're using this standard metric of carbon dioxide or carbon dioxide equivalent. Building decarbonization is the process of reducing this. And it, again, I addressed that it's decarbonization. We don't have to go to total zero carbon at this stage. But what we need, as Dwayne addressed there a minute ago, we need to build in how can we move toward that zero carbon. Now, for buildings, there's three things. First of all, the building design and the construction. That's a big part of it. Then we have to talk about how's the building operated, and also how's it occupied. Why is this important? Well, global human emissions must reach net zero by mid-century in order for us to limit our climate change to substantially less than the 2 degrees C. And the International Panel on Climate Change, that was a statement that was made 3 years ago. And what I've gotten here at the bottom is some of the sources of this. The National Academy of Sciences, NAS, has some great resources that are available to us. The second is that the World Economic Forum says that we need full decarbonization of our energy systems by around 2070. So we're first talking about mid-century reaching net zero, but then all of these by 2070. Then finally here, this last bullet is that we have a large number of nations, we've got a large number of cities, states, a large number of companies have made this commitment already. And so what we need to do is be able to address these. Now, why is it important to ASHRAE? Well, direct building emissions need to be cut in half by 2030. That's a big step in front of us. In order for us to get to that net zero carbon that was addressed in there a minute ago, we've got to get to about half of that in the next 10 years. buildings are one of those areas. We've got a lot of different areas talking about decarbonization, but buildings in particular are a major area that lack specific mitigation policies. And so what happens is that we in the building industry need to be addressing that. Sorry for that interruption. My 4-year-old grandson just came in the door there. Sorry about that. But what we need to realize is that we have 136 countries have already submitted the NDCs, or the nationally determined contributions. And out of that 136 countries do mention buildings as a specific way of reducing those emissions. 53 countries mention building energy efficiency. They are already building that into it. And 38 specifically call out building energy codes. They don't necessarily say what it is, but they say this is important for us. So the question is okay, where do buildings fit into this total production of CO2? If we look at the energy that's being used, and these are global numbers of a couple of years ago, the latest things that are available from the International Energy Agency, which is the international group that keeps track of energy flows. So what we're seeing is that 35% of the energy worldwide is related to buildings. About 22% residential, 8% non-residential. And then what a lot of people don't think about is just the building construction industry is a very significant factor as well. So 8% of 5% of the total energy being used is related to construction of buildings. So if we take that and translate that and say, okay, that's the energy consumption. What about the emissions? So 38% of the worldwide emissions of CO2 are related to buildings. And we have both direct, which is the direct use of the buildings, and the indirect, which is that carbon that is produced when we are producing electricity. So we see that for non-residential, only 3% is in the buildings themselves, and this is related to that gas usage that Dwayne talked about there earlier, is one of the big parts of that. 8% related to the production of electricity for non-residential. In residential, we see we've got indirect and direct, again, about 17%, and the building construction industry about 10%. The bottom line is more than a third of the emissions of CO2 in the world are directly related to buildings, something that we are needing to address. So why is ASHRAE involved with it? Well, if we look first, of course, there's that direct correlation between the energy usage and the emissions. ASHRAE is the worldwide standards authority for energy usage and for efficiency in buildings. Our standard 90.1 is used worldwide. The other component is, remember I said earlier, it is not just a city problem. It's not just a state problem. It is not a national problem. It's an international problem. ASHRAE has chapters in over 130 countries. And we all know that the authority having jurisdiction is the final say in what gets built in a territory. So therefore, having chapters with feet on the ground influencing those authorities having jurisdiction, providing them with the educational input, is something that's going to be critical for us to be able to achieve the goals. So what ASHRAE can do is put some overall guidance that then we can look at the entire world and make a difference. So let's shift a little bit and say, well, okay, if it's international, where are these being produced? Well, a couple of things here. So about half of the total CO2 emissions, man-made CO2 emissions, about half of those that have been between 1750 and 2010, a long period of time, about half of those have occurred in the last 40 years. Half of the emission growth has been in the last 40 years. Well, if we look at it, we've got 44% is in our developed countries. Economies in transition, those economic developed countries are developing countries. Asia, about a quarter. Latin America and Middle East and Africa are much less because they don't use as much energy. So, key component here, in the last 40 years, we've had about half of the total emissions being produced during those times. So, we've got a number of countries that are involved in trying to address this problem. And this is a graph that you see here, the various colors. Those that are dark green are those developed countries that actually have some restrictions associated with it. Those that are in lighter green have less restrictions. And then the developing countries in orange are also getting this in motion, and those in red are those that really are project level type of decisions. They're not nationwide policy decisions. The bottom line here is that it is a worldwide problem, and we see people are addressing it. If we look at the U.S., we see, and this is it's a few months out of date here and these are growing all the time, but we do see that we have a lot of cities that have policies and states that have policies in them. And these dots are increasing rapidly over time. So we've seen what the emissions are. We've seen where they're occurring. How do we try to hit those targets? Because those targets are set, but we don't have real goals, or we don't have real procedures. We don't have good information on how to hit those goals. Well, really, there are three major legs to this stool. The first is energy efficiency. The second one is switching to a cleaner energy source, whatever that might be. Typically, people are thinking of electrification at this stage of the game. And the third major one is then let's take our electrical production and let's move that to more low carbon energy sources. Renewables, of course, is the major thing that we're talking about here. So those are the three legs of our hitting the targets that we are addressing in decarbonization. The International Energy Agency has some discussion on how to get to net zero by 2050. In this roadmap, I would suggest you look at the reference here, and this is a summary of several hundred pages. And what we see is between 2020 and 2030, we're going to be hitting well, in that time period, we're going to have a 24% increase. But in order to reach that 50% reduction, we've got to look at a number of these different measures. The yellow, energy efficiency, the light green, wind and solar are renewables, and electrification is in that light blue. That will bring us down to that 50%. Then between 2030 and 2050, again, because of growth, we're going to have more usage. But then what kind of measures are we going to have to implement in order to get down to that 100% reduction? And we see avoided demand, that dark purple is a big chunk of it. Between 2020 and 2030, we have a lot of energy efficiencies, so the potential for additional energy efficiency is going to be lessened. And you'll see there that electrification and moving to electrification is going to come into play between the 2030 and the 2050. Then that orange there at the very bottom, the combined or the carbon capture we see is really being the potential and one of the salvations in order to hit those goals by 2050. So what are some of the issues now that we're having to address? I think one thing that everybody must remember is that one size doesn't fit all. We've got residential, we've got commercial, we've got industrial. The same thing won't fit for all of those. Then we've got to think about, okay, we've got new, we've got retrofit. The majority of the buildings that are going to exist in 2050 are already existing. And then finally, we need to look at, it's not the same thing is not going to be the same, or I'm sorry, what is needed is not going to be the same across even America. So we see that this two pie charts here in the bottom right, the one on the left is what's our generation mix for and this is Indiana, Ohio, Western Pennsylvania, and West Virginia. And we see that fossil fuels is about 2/3 of the electrical generation. However, if we look at upstate New York, we see that fossil fuels, rather than being 2/3, is about 1/4. Hydro and nuclear being the other big sections. So that is in America. But then if we look at developed and undeveloped countries, or underdeveloped, look at Canada here. They have about 60% of their electrical production is by hydro, and there's only 18% of fossil fuels. If we look at Europe, the European Union, we see that it's about 40% fossil fuels, a big chunk of nuclear as well. But yet, if we look at Southeast Asia, we see that over 3/4 of their energy is being from fossil fuels. So one thing doesn't fit all cases. So we have to make this comparison between developed and underdeveloped countries. All of those are a big portion, or a big problem that we must be addressing. Another big thing that we need to be addressing is definitions. There is a wide spectrum of definitions for the same thing. Net zero, what's net zero carbon? What's the operational carbon? What is the embodied carbon of the materials that go into our buildings? Whole life carbon. Let's do the life cycle analysis of what the carbon is, from the mining of the ore to production of the steel to use in the building to then the dismantling of the building. And then finally talking about upfront carbon. So CIBSE, the Chartered Institute of Building Sciences, which is out of the UK, has standards associated with some of these definitions, and those are not the same as many of the other parts of the world. In addition to that, we see that based upon those definitions, we also have standards and codes, and we see that there's a lot of different energy codes, and we see that sometimes they're mandatory. Sometimes they're mandatory for parts of it. Sometimes it's just major cities. Well, and then we have some places where there isn't a code. The key component here is that even if we do have building codes, they're not uniform. Okay, so as we look at the standards, we've got the scope of it. What are the metrics? What we're going to have to do is transition our building codes from energy-based codes that they currently are to carbon-based codes. And I think we'll see a migration of our standards and codes to that. Another big component, and this is to provide that flexibility. We recognize that what we're going to have to do is performance-based standards, or performance-based building codes, rather than just saying this is prescriptive. This is going to present some real challenges to those AHJs and how those authorities having jurisdictions. It's going to present some challenges for the building code officials in implementing these. There's questions on on the codes, are we talking about site or source energy usage? A big difference between those two. Do we use carbon emissions or do we use some other metrics as a benchmark? We talk about comparing against benchmarks. What do we use as that? And then finally, when we're talking about equipment, equipment is used worldwide, but there's a lot of disharmony on what the labeling is and what the reporting is for those. I talked about metrics there a minute ago. That is a major issue for us. We talking about energy use, or are we talking about carbon? And are we talking about embodied and operational, or are we just talking about operational? All of those metrics still are not defined well. What are the offsets? What are the trade-offs? Some standards allow it, some standards don't. What are we talking about the benchmarks? Do we include plug loads? Do we not include plug loads? And then also embedded carbon. What is the carbon that it is in a product? What is the embedded carbon of making that product? And if that product is made in location X as opposed to location Y, which is close to the sources, you'll get different numbers. All of these metrics still yet need to be determined. Another one is, we have generation that where the generation is coming from or where the electricity is coming from is generated by a number of different sources. And this is a graph that one of our local utilities has, and the family of lines that are going across there is the daily demand for all 365 days a year. So you see the lines down at the bottom. Well, we're not using much energy then, and that is covered by our base generation. But then as we start having the variation and demand changing a great deal, we've got to go with generation that is able to respond quickly. And typically those are things that are more expensive, but yet the carbon changes as well. So as we look at where the generation is coming from and what energy source is used to generate that electricity will greatly impact what the operational carbon of the building is. So this brings back to the figure of when are we using the energy? Can we use a low carbon energy source and store it and use it at a later point in time during the day and do load leveling and carbon leveling? A bunch of other issues, refrigerants, we've talked about that. Dwayne talked about that. Energy storage, we're seeing thermal, we're seeing a lot of electrical energy storage research that's going on. Just controls, having the building to be able to respond to grid signals, and conversely, the grid responding to building signals. Maintenance and operation and the complexity, the more complex the building, the more difficult it is to operate. Buildings follow the laws of thermodynamics. They always go downhill. So maintenance and operation, we cannot have a more complex system that our building operators are able to maintain and operate. Commissioning and retro commissioning, that's one of those key factors that we must keep in mind as well. One of the big unknowns is, where does the electrical energy used in vehicles? Is that in the transportation section? Is that in the building sector where they're plugged in? How much and what's the penetration of electric vehicles? Those are some real questions that we all must be addressed. And if we're talking about having electric vehicles being charged at our buildings, how does that fit into our building energy codes or our carbon codes? Dwayne addressed already the grid security and capacity. And then finally, this linkage between guides and standards and codes and the authorities having jurisdiction to be able to implement those. We currently don't have a good number on what's the carbon cost. We have good numbers on energy, but what's the economics associated with that? I was recently doing a energy assessment on a manufacturing facility, and they had just put in a $15 million solar system. And I asked them what the economics of that were, and they says, we never did calculate. And I says, you put in a $15 million addition to your facility. How did you run the economics on it? And I said, our company wanted to be perceived as a green company, and it came out of our advertising budget. How do you fit that into the economics? Those types of questions are very difficult to deal with. So what can ASHRAE do? How are we working with this? Well, first of all, we're developing a web presence. We're pulling together a lot of different issues that we're trying to put onto the web. We are developing best practices, pulling those items together. Guides and guidelines, a big component. Standards, we're talking about building performance standards. We have to be doing the benchmarking and what is our existing stock assessment. Where is our baseline? And then and Doug's going to be talking about our training and education, and certainly ASHRAE is going to be able to work with this on an international perspective. So this is just some of the things that we're trying to do. Certainly feel free to ask questions. Be glad to discuss this further. So thank you for your time.
Thank you, Don, for a great, well-informed presentation. And next, we're going to hear from Doug Cochran, and his presentation will be the Task Force for Building Decarbonization, Training and Education update, and as well as the efforts, the Canadian efforts. So, put the floor to Doug, and thank you very much.
Yeah, I'm just trying to bring this up. I'm not sure what's going on here. The share is blocked out. Well, maybe it'll work now.
Hey, Doug, and I'll make the offer to you also. I could always share my screen, and if you want to tell me next, we can do that.
Okay, let's do that, just because I don't know what's going on here. I know we're a little bit behind time, so I want to keep this moving. If you'd be so kind as to bring that up, and I'll tell you next slide. So while he's bringing that up, I just want to say that the Training and Education Working Group appreciates the time. We think it's important to try and get as much information out there and develop tools to keep everybody informed. Decarbonization is a big buzzword these days. There's 7 people that are part of the group, led by Don Brandt, who is a Society Vice President. We have representatives from government, from consulting, from equipment manufacturers, and also a utility, people from the US, Canada, and Greece. So we're trying to get that international flavor as part of this working group. Next slide, please. So what I want to do today is sort of bring you up to date as to where we are with this group. Right now, we have 4 seminars that have been slotted for the ASHRAE Vegas meeting. There'll be an update on the task force on decarbonization. There'll be an introduction to building decarbonization, talk on the building grid and carbon sequestration, the Research Knowledge Hub, and building standards. And we're also going to do 1 seminar at the AHR Expo, which will be on appliance and equipment standards. And the other thing we've tried to do is, so that every working group within the task force is represented, we will have we're working on a seminar now for early January, prior to the Vegas conference, to make sure that we cover the other working groups, which are embodied and operational carbon, and also building codes. Next slide. The next thing we're working on is the next meeting for Toronto, or for ASHRAE, is the Toronto meeting in June. And what we're working on there is to have 3 ASHRAE Learning Institute courses on decarbonization. What we've tried to do is align these with the way the ASHRAE handbooks are set up. So the first one is fundamentals. It's going to be an introduction. The second one will be based on systems and equipment, and the focus on that is going to be on design, and we will be covering the various equipment types as well. Thirdly will be applications, and this is really a focus on the operation of buildings. So we think it's key to have, people know what decarbonization is about, how to design, and also how to operate buildings. And then the other thing we're working on is there will be an international decarbonization conference in Athens, Greece, October 6th and 7th, 2022. It's a great way to combine work and pleasure. If you've never been to Greece, I highly suggest you take a look at that. Next slide, please. The other thing we're working on is papers on decarbonization efforts in different countries, and we want to do that globally. We want to get a good perspective of what's going on around the world. These will be developed into journal articles and will probably be used in that global conference I just talked about in Greece. So we've come up with a framework so that we're going to have consistency of papers around the globe. Canada is the first one that's currently underway. We're currently working on that. The rest will follow. I know Don is involved on the one for the US. And you might recognize some of the names there, people, ASHRAE members, a couple of people who've been involved in your region, Region 11. Bill Dean is heading up the general overview from Canada on a national basis. Eric Binder from Calgary is going to handle Western Canada, so Manitoba and provinces west to the West Coast in BC. And I'm heading up Eastern Canada, Ontario, and East. Next slide, please. So what I want to do now is sort of give you a summary of what's going on in Canada, just to give you some perspective of where we are and sort of things that we're putting together. So in 2018, Canada produced 647.7 terawatt hours of electricity. And as you saw from Don, 61% of the electricity is generated from hydro sources. The rest is a combination of natural gas, nuclear, coal, biomass, solar, petroleum, and wind. Our electrical regulation is at the provincial level. And currently there's only 2 provinces that are deregulated, that being Alberta and Ontario. It's interesting that BC, just north of Washington there, Manitoba, Quebec, Newfoundland and Labrador, and the Yukon are all over 80% from hydroelectric. Quebec is almost exclusively electric, coming in at 95%. The rest of the provinces rely on a combination of nuclear, hydro, wind, biomass, coal, natural gas, and petroleum. Next slide, please. The goal in Canada is to be net zero emissions by 2050. And Canada has this Net Zero Emissions Accountability Act, which was passed last year. We've had an election. We ended up with the same party ruling. However, it sort of delayed putting everything together to make, the steps necessary in order to make that work. What that will have is a series of interim emission reduction targets at 5-year levels as to what we're supposed to achieve. They've also developed a net zero advisory board comprised of 14 individuals across the country. And they've committed $3 billion to establish a net zero accelerator fund to help large emitters reduce their emissions. One thing I just noticed is the province of Quebec has a satellite firm that is looking at what is going on with carbon, so what carbon is going on and what the reduction is. They've given them money to be able to come up to improve what they're doing. And Canada does have a carbon tax, currently $40 a ton. In BC, it's actually $45. That is rising, and it'll be $170 per ton in 2030. Next slide, please. The COP26 that just went down, these are the highlights of what Canada has promised. So we have agreed to the 1.5 degree Celsius global warming target, established plans for international shipping. The next one is sort of very aggressive. They want to cut emissions by 40 to 45% by 2030. It was 30%. Canada is currently a little behind the goal, so to try and achieve that is definitely going to be a challenge. A clean electricity grid by 2035 to cap the oil and gas emissions at current level. As you probably know, a lot of Western Canada, there's a lot of oil and gas, so that's a big thing. And you'll look at the next one where they want to cut the methane emissions from all oil and gas by 75% by 2030. So we want to make sure that we reforest. We had a number of forest fires, as I know you've had in the Western United States as well. So that is going to be a challenge to be able to get that all done, and managing all our oceans that come under us in the next 5 years. The other thing, making all electric vehicles by 2035. And also there's something in place for commercial vehicles as well. Next slide, please. Canada has a national building code. They're currently trying to streamline this with the provinces so that everybody can adapt it and then make changes that they want to have it more stringent. The changes are due out shortly, and part of that is the National Energy Code for buildings. What they're doing is much like what's going on in BC that has that STEP energy code. This is going to be a 4-tiered code that is performance-based. So you'll see more things coming out on that. I will point out that the Canadian Green Building Council has their own zero carbon standard now in the second version, which can be chosen to be followed. It's not obligatory, but it is officially recognized by the province of BC. Next slide, please. This is just some links here that you can see the initiatives that are going on in Canada. Next slide. I'm going to switch gears to Ontario here. You can see the mix for Ontario is much different than, say, it is in BC, which is at least 80%. We have our majority of electrical production is by nuclear. The province does have an energy reporting system, including water for buildings 50,000 square feet and larger, the EWRB. The one thing where I think it can be improved is you have to report and you can see what you're doing in comparison to other buildings, but there's nothing there to tell you what you can do to improve. So something like ASHRAE's building EQ can be used, where you can actually get out of the program what you can do to do that. So this uses the portfolio manager, and with the building EQ that we have with ASHRAE, that's something that you can import the data from portfolio manager directly into building EQ. The other thing the province has is the Save On Energy. It's been around now for 10 years. You can see there's been 220,000 projects, and they've saved 13.6 terawatt energies of energy and reduced demand by nearly 2,000 megawatts. Just happened here in November. Ontario is the first province in the country to come up with what they call the Green Button platform. So basically it's giving customers not only a choice of how they want to structure or how they want their hydro rates to be, either, you know, a tiered thing or a scalable thing. It's going to be your choice, but you're also going to be able to get that stuff in a usable form that you can put into whatever app you want to help you try and improve your energy efficiency. Transportation sector accounts for roughly 30% of emissions, and that's very similar to what Don's already shown you for what happens globally. I think one of the interesting things is in 2018, there was 2.9 gigawatts of solar produced in Canada, and 98% of that was in Ontario. Next slide. Toronto has what they call the Toronto Green Standard. So this is a standard that is more stringent than the Ontario Building Code that people have to follow. So version 4 was just passed in July. Details will be fully published in 2022, but it will apply to all new developments starting May 1st, 2022. One of the great components that I think is in there is that it also has a net zero existing building strategy for decarbonization of all buildings, which will be mandatory in 2025. As we've said, most of the building stock that exists today is still going to be here in 2050. So I think being able to retrofit existing buildings to help lower the carbon or greenhouse gas emissions is going to be key across the globe to be able to make this a more sustainable world. So the Transform TO goal is to, get to net zero greenhouse gases by 2050 and reduce emissions by 30.6 megatons by then. So it's a 4-tier approach. Tier 1 is compulsory. Tier 2, 3, and 4 are elevated. And if you follow those, you may get a refund on development charges, which can be significant. Toronto is one of the largest growing cities. We've got a lot of cranes up, a lot of condo development. So I think it's a key thing moving forward. And one of the things I found interesting is Toronto also has an energy loan retrofit program, which offers low interest loans of 100% up to 20-year payment. And so what they're really doing is offering consumers the same rate that the city can get borrowing money. Next slide. Switching gears here to Alberta. Alberta is very heavily into oil and gas, but some of the players there are making big strides to do it. Dow has put $10 billion into the world's first net zero carbon emission ethylene cracker. TC Energy has linked up with an electric truck manufacturer to develop large-scale hydrogen production hubs in North America. And you'll see a number of companies in Alberta are trying to embrace this energy transition in areas such as hydrogen and carbon capture to try and do more to make things work. Next slide. British Columbia, just north of you there in Washington, has the Clean BC plan. And the whole thing there is to reduce climate pollution and build a low carbon economy. They want to switch to cleaner BC electricity, get away from fossil fuels, and try and use renewables. So they're really trying to get energy efficient solutions and trying to make them more affordable by offering various incentives to people. And also new investment in industry, to try and get lower carbon products and services. Next slide. So there's the Clean BC plan. You can sort of see in that pie chart how they're trying to achieve that by 2030. And you'll see the amount of megatons based on what you have. So for industry, 8.4 megatons of CO2 equivalent. Buildings, 2 megatons of CO2 equivalent. That's what the targets are. Let's hope everybody can reach those. Next slide. Here's some of the highlights of the Clean BC plan. And you'll see included in this is what the actual megaton of carbon reduction is planned to be by 2030. I think one of the key things here is every new building in BC will be net zero energy ready by 2032. Like we said, BC has that stepped building code. So it's very interesting to see, and they've taken it further to include the the waste as well. And the province, the industry, they want to lower it by 8.4 megatons by 2030. Next slide. So from fossil fuels to clean energy, again, that drive to get to clean and renewable resources. Nearly 3/4 of the energy used across the economy still comes from fossil fuels, and we definitely want to get away from that to try and lower our carbon output. Next slide. Better buildings. So this is part of the BC Building Code. We've already said net zero energy by 2032, but you can see some of the numbers here. 20% better by 2022, 40% better by 2027. And to get to that net zero energy ready is 80% better by 2032. Some pretty aggressive targets. So they want to introduce more support for better buildings and home retrofits. They're going to upgrade their public housing, incentives to make heat pumps more affordable. One of the things I think that's interesting in here is remote communities. It's a big issue in Canada. Most of our population is by the US border. So remote communities have some unique features that have to be taken into account. Next slide. So we want a cleaner industry. Direct a portion of the carbon tax paid by industry into incentives for cleaner operations. So put some of that money back in to help people reduce their emissions. And you can see everything here is, reduce emissions. They want to get to industrial electrification, cleaner fuels for industry, and reduce the carbon pollution by 8.4 megatons by 2030. Next slide. Reducing emissions from waste, we've sort of covered that, and that's 0.7 megatons by 2030. Next slide. I just wanted to sort of highlight what's going on in Vancouver. Their heating and hot water system, zero emission by 2025, and transition to zero carbon starting April of next year. Their 2030 goal is a 40% reduction in carbon emissions over the 2007 levels. And improved energy efficiency for residential projects, 3 stories and under, starting January next year, and meet the STEP BC code for residential in 4 to 6 series is already in place as of January 2021. One of the other interesting things that's going on in Vancouver is there is a district steam plant in the downtown core that is going to be changing from natural gas to electricity, and it's going to be expanded so that it can take in more to have a central heating plant for more of what's going on in downtown Vancouver. So that's sort of a snapshot of what's going on in Canada. Again, thank you for your time. It's been my pleasure to present. And the last slide is just for questions, and I guess we're going to have open it up for questions. So I'll turn it back to the panel.
Thank you very much, Doug, for a very well-informed presentation. Okay, we'll just give a couple of minutes for questions if anybody wants to, type in their questions. There's some happening already, and I think Christian will perhaps read a few of them.
Yeah, so it looks like Holly Towns sent a message to Puget Sound ASHRAE about sending a support letter. Holly, I don't know if you saw in the chat, but I should have you should have received an email from me regarding that. Holly also asked if presentations will be made available. They sure will. So we'll send that out to the original mailing list in PDF. And I guess, one of the questions that I had for the 3 of our panelists, Doug, Don, Dwayne, I guess how, Doug, you talked a lot about some of Canada's building decarbonization efforts. And I was just wondering if you knew at all how that might compare to what we're doing here in Seattle and potentially in Washington State.
Helps if you hit the unmute button. You know, I learned a lot hearing Dwayne talk about this as to what's going on in Seattle and Washington State. Not being from there, I'm not as familiar with what's going on, but I'd, you know, be happy to answer what's going on. It's just because I've been working on the Canadian paper, that's sort of what I've been concentrating on.
Absolutely, that makes sense. And I don't know if Dwayne's on anymore, but Don, were you going to say something?
Dwayne is on.
Oh.
This is Don, and I can't answer that. I think Dwayne would be the one to respond to that, if you can, Dwayne.
Well, one question, that Canadian standard is not necessarily adopted by anybody, is it? It's not mandated by the feds to be adopted, and so my question actually back to Canada would be to what's the actual influence, and how about some of those more recalcitrant provinces in the middle? Are they going to be getting on this wagon?
I think everybody will be. Like I said, there hasn't been a lot of meat. There's been a lot of promises, but not a lot of details as to how this is all going to be achieved. So I think it's going to be key that people get that information in order to do it. And individual provinces, depending on, you know, where you are, how you're going to achieve those goals is going to be an interesting thing moving forward.
I find a basic sort of cultural difference between our codes here and Canadian standards, that I think Canadians are just, because they're so damn polite, they just have a hard time telling anybody what to do. And so they try to be nice and offer extra building height or do nice things for people so that they will do better buildings. I'm not sure that that's an effective, it's effective for the people who are already going to go forward anyway and do something big. But I think Vancouver, by contrast, now is moving much more aggressively towards a heavily mandated code that you just got to follow.
Yeah, like I said, British Columbia, I think, is the most progressive of any province in Canada currently. You know, 2/3 of our population are in Ontario and Quebec. Quebec being already 95% hydroelectric, they have, I guess, less to do than some of the other provinces. So it'll be interesting to see what happens moving forward.
I would object to that, because I think I mentioned in my talk that even if you've got a big hydro resource, to switch all your transportation over is going to take a chunk of that resource, and I think that a lot of the eastern seaboard in the U.S. is interested in acquiring chunks of that Quebec hydro to try to make their portfolios work. So I think the only way we're going to make things happen is to have both stringent efficiency standards and decarbonized energy supply, not one or the other.
I agree. Everybody's got to work together to achieve the goal.
Christian, didn't we have some more questions or complaints or outrage from the audience?
You know, we actually didn't.
Okay.
I have a question for I guess it'd be Don. Don, if you're still there, right?
Yes, sir, I am.
Okay. Well, you had mentioned in your presentation that they're suggested to move from the energy codes from energy codes to carbon-based codes. And I wanted you to talk a little bit more about that. Is that happening? Where is it happening? What's the driver in that? And what are some of the roadblocks to making a carbon-based code from an energy code?
Great question. And I wish that there was an answer to it and a magic bullet. I think what we're seeing is that uh, as we see, well, first of all, uh, the U.S. is way behind the rest of the world, Europe in particular. In my visits in Europe, even 10 or 12 years ago, they were not talking about the energy usage index or kilowatt hours per square foot per year. They were talking about pounds of carbon per year, per square foot or per square meter, I guess. And so it is a transition that North America has been in this issue with energy, and it's not an easy question on how we go about doing it, but it's a realization that it must be done, and there's a whole series of questions that need to be answered before we do that, and that those issues that I was talking about, that just the energy mixes over time. And if we're talking about when is the energy being used, so if the energy is being used, say for instance, during the peak solar radiation time, you're going to get a different carbon usage than if it is at midnight on a cold wintry night. So I guess I'm not beating around the bush other than to say that that is a great question that has to be resolved. But the Europeans have done this, and it's been in existence for years. The EU has, in order for you to sell a building, you cannot have more than a certain number of pounds of carbon or kilos of carbon per square meter per year. They certainly have done it. And so we need to be looking, and we need to be harmonizing worldwide how we're looking at this issue.
And in Washington State, we have, in fact, just used the energy code and converted it by agreed upon factors to carbon. And that's how we do our modeling and our HVAC evaluation and everything else.
And that's not a trivial thing to do when we're talking about a international code or even a nationwide code for a particular city where you do have a pretty consistent energy source, and and I guess I'm curious on how you take into account when the energy is used.
Well, it helps that we have a gigantic hydro resource here, which the
Right.
utility Bregs, they adjust 20 times per second to deliver just what we need. So we've got a cushion there that most parts of the country do not have.
That's right. And so, California has run into issues, or has run into basically, and I notice Andy says the California's T24 certainly does have that time dependent variation of where we're talking about that energy carbon metric.
It does look like Andy also has a another question. How can we evaluate and set targets for how to best balance efficiency or reduction versus offsets when it comes to decarbonization? And I will also say that we are, a few minutes over 7 o'clock. I'm okay staying over. I'm not sure if our panelists are. We want to be respectful of their time, and I know that both Don and Doug are on the Eastern time, so it's pretty late for them. So Don, Doug, and our panelists, whatever you're willing to do, I'm also willing to do.
Well, I'm open for a few more minutes. I've got a early meeting in the morning, so.
Yeah, maybe let's cut it off in 5 or so minutes.
Okay.
And that could be our last question there.
That's fine.
Okay, so I see Andy's question, how can we evaluate or set targets for how to best balance energy and efficiency versus offsets? It's a great question. And I'm not sure I have the answer to that. I think what we're seeing is this is pointing out some of the issues that we need to be addressing. And it's meetings like this to put together folks to know what the issues are so that they can be addressed and not come up later on. So certainly, Andy, I thank you for that question, and it's certainly one that we need to be addressing.
I would say that by 2030, it needs to be all of the above. We need to have on-site renewables. We need to have extraordinary efficiency and probably some off-site renewables and other things, storage, and others that will sew that all together. So do is very opportunistic. We push the efficiency side as far as is, technically and economically practicable, and then we're going to just have to build up the other side of the equation to accommodate the energy that we that we can't take care of with efficiency. I think a Seattle office building is efficient enough that it's nearly 50% of all the energy used will be non-regulated at this point.
That is a great point, and I know some of the best designers, and I talked to the designer of the first net zero energy school in America, and his role was, let's cut our energy consumption, let's reduce as much as we can, and then fill in with renewables. I think where the balance is, as renewables become less and less expensive, it's a question on the challenge is, okay, if I can easily put in renewables, that means I don't have to have my efficiency quite so large. And that I think is a balance that we need to be addressing as well. It's just because we can put in more renewables, do we need to be doing that? And that gets into the component of embodied carbon. I'm not hearing a lot of people talking about what's the embodied carbon of the various materials. And if we were to look at, building materials, just the cement manufacturing, if just cement manufacturing was a nation, it would be the third largest carbon production source or the third largest country behind China and the US. So the embodied carbon of our building materials is a large part as well.
Don, I have a question for you, or I guess the panel in general, but I guess how do you see load shifting and demand response play into decarbonization and what ASHRAE is doing, and how important do you think that is?
It is a tremendous part to it. And in fact, we have one of our task groups is just talking about the building grid interaction, and actually another group is talking about the operational carbon, which is that connection. One of the groups is talking about the signals from the grid giving to the building. The other group is talking about what the building signals are going back to the grid. So just communications is one of those big areas that we have people working on, and certainly storage is one of those big components that that we see is critical to us.
I think the way to look at this is to look at the whole society and what's getting us our best bang for the buck. If you have to build a grid that's so big that at the very most horrible wintertime peak of the year it can accommodate everything, it's probably twice the size that grid needs to be. And so at that point you have to say, well, it would have made more sense to shift some of that water heating load and that car charging load over to a different time period and shave off that peak. And so I think we just need to be back and forth balancing out what are the things we can do, looking at the big picture, that get us the furthest with the least pain.
Yeah, this is John here. I think a piece of that is the battery side of it too. I mean, as I think everybody's expecting battery technology to get better, and so 100% of load all the time, that becomes less necessary.
I was recently involved with Tennessee Valley Authority's integrated resource plan, which is saying how do we predict what our generation needs are for the next 20 years? And it was a least cost optimization problem with several million lines of code in their linear programming model. And what was driving, and so bottom line is the Tennessee Valley Authority, TVA, is going to be putting in as the least cost option in the 11 to 12 year time period. They're going to be putting in 50,000 acres of solar panels. And the reason that it was not more than that was because of the unknown related to battery storage. We are seeing more battery storage technology is coming along, but that really is what's the one of the big unknowns at this stage of the game, John.
Yeah, I got to sign off. Good night, everybody.
All right, thanks, Dwayne. And yeah,
Thanks,
we did reach time. Holly, I'm so sorry that we didn't get to your last question of concrete and getting clean energy and solving that embodied carbon issue. I don't know, Don, if you could answer that in a yes or no, but I think I'll be sending out the slide decks if you want to get in contact with each of our panelists. I believe their emails may be on those slide decks. I'm not sure.
Mine is.
Okay. And I believe I saw Dwayne's and Doug's as well.
Yeah.
Okay. Well, thank you so much, panelists. Thank you, moderators. Thank you, everybody. Thank you, ASHRAE, and thank you, everybody who's able to attend. I think we'll go ahead and call it a night, but what a wonderful presentation, and thank you so much, everybody, for attending. So take care, everybody.
Yeah.
Thank you for the
so much.
opportunity
Thanks,
to meet
everyone.
here.
Everyone.
Yeah, thank you.